Memory hierarchy. This lecture is about memory hierarchy. These are the outline topics of this lecture. So, importance of the memories, computer system, memory hierarchy, comparison of size, access time, cost per bit for the memory hierarchy. To provide knowledge on organization and different types of the memories in the memory hierarchy. Second one is to compare size, access time and cost per bit for the memory hierarchy. So, always we used to think that one processor is much more important than the memories, but I can tell that. So, processor is much more important and all memory is also as important as processor. So, one without other cannot exist. So, that is how I can define. So, there is a the way the processor is very important, that memory is also important here. So, memories are categorized into different types based on the various characteristics. So, I am not going to give you a detailed discussion on characteristics, but I will give you the very brief overview on this one here. Location, if you take this, the memories are categorized into internal and external based upon the location. Internal in the sense within the CPU. Outside of CPU, cache memory, main memory and an auxiliary memory. Capacity, so that could be measured capacity, it could be what you call it as bytes, blocks or so on like that here. And then access methods, there are various access methods are there. By using these various access methods, the first one is the sequential access, the second one is the direct access, third one is the random access, fourth one is the associative access. Performance, how these accesses could be retrieving the data, that could be the called as a performance. Performance could be measured by using the various parameters like access time, the time required to access particular location of the memory, and then cycle time, the time required to access the particular location, and then time required to locate that particular record, both together called as cycle time here, and transfer rate, rate at which it is transferred here. Physical types, there are three physical types are there here. One is semiconductor type, second one is magnetic memories, third one is optical memories here. Physical characteristics, volatile, non-volatile, erasable, non-erasable. These are the various characteristics of the memories. But by and large, the memories are organized in such a way that which one could be accessed first by CPU, and then which one could be accessed by the CPU next. So, the order of priority for the accessing the data by CPU or accessing the instruction by the CPU from the various parts of the memory here. So, CPU registers first, this is the internal, based upon the location we could categorize this one as the internal location. Second one is the cache memory, external, main memory, auxiliary memory. This is how this could be organized here. Now, you see here CPU registers are small in size. Okay, let us see that these things in sometimes. So, the way this is a processor. What does it do? The processor will go to the CPU registers and fetch the data from the CPU. The speed of the CPU registers are same as to the processor. Since these are all located on board, these are all located on board here. These are all located on board here. The next one is the processor goes to the cache memory if that is not available in the CPU, and then it will fetch from the cache memory. And then if it is not also available from the cache memory, and then it goes to the main memory and fetch from the main memory here. And then this is very important. CPU could directly goes to the CPU registers, cache memory and main memory. CPU can't go to auxiliary memories directly. If at all something it has to be accessed from the auxiliary memories, that has to be done through main memory here. So this is how. So and also cache memory having the direct connection with the CPU registers, main memory having the direct connection with the cache memory. Moreover, main memory having the direct connection with the this one also. You could see here. So main memory content directly can be copied to the CPU registers here. You could see, you could observe here, auxiliary memory, content of the auxiliary memory can't be transferred to the CPU registers directly. If at all you want to transfer, that could be transferred only through the main memory here. Okay, that is so let us see that one. What is size? This is how the memories are, various memories are organized here. CPU registers, cache memory, and main memory, auxiliary memory here. Now the size. So when you take the size, consider size, CPU registers are smaller in size and limited in number, smaller in size and limited in number. Cache memory size is bigger than the CPU registers. Main memory size is bigger than the cache memory, and then auxiliary memory size is bigger than the main memory. So when the size of these memories in the memory hierarchy from the CPU register to auxiliary memory, it is being increased. So CPU register to the auxiliary memory size is increased. Other way around, you may be asked a question. What is the size, how the sizes varies from the auxiliary memory to CPU registers in the memory hierarchy. Then when you refer from the auxiliary memory to the CPU registers, then you have to write that one, size decreases. But if you refer CPU register to the auxiliary memory, the size is increases here. All these discussions took as like this. So memory hierarchy, access time, memory hierarchy, access time here, and then memory hierarchy, access time is what is access time? Time required to access the particular location of this memory. That means CPU, how much time it takes to access the CPU registers, how much time to access the cache memory, how much time to access the main memory, how much time to access the auxiliary memory. But the CPU access time is very it is almost as same as the processor, So when you say that one access time is also increases here. So from the CPU register to the auxiliary memory, because the size is increasing here, and then then what will happen here? The access time is also increasing from the CPU register to the auxiliary memory here. Now you see here cost per bit here. So what about the cost here? When you take this one, so CPU registers are very costly. So cache memories are cheaper than CPU registers, main memory is cheaper than cache memory, auxiliary memory is cheaper than the main memory. You could notice the difference. Suppose when you want to buy some main memory, so if you want 16 GB, it might be cost around 5,000, 4,000 nowadays. Okay, and then it is just for 16 GB RAM, 16 GB RAM, 16 GB RAM. It costs around the 4K, 5K. Okay, when you go to the auxiliary memory, such as hard disk, pen drive, and so on, and then you see here 1 terabyte hard disk is cost of around the 4,000 to 5,000, whereas 16 GB RAM is 4,000 to 5,000, and 1 terabyte hard disk is also 4,000 5,000. So you could understand that one, auxiliary memories are cheaper than the main memory is cheaper than the cache memory is cheaper than the CPU registers. In that context, because that is why the cost per bit is decreasing from the CPU registers to the auxiliary memory, some from the CPU register to the auxiliary memory. Let me try to give the comparison here among all these memories. So the memories are organized as like this, and then you see here the first point is size. Size is from the auxiliary memory to CPU registers if you take in other way around, and then auxiliary memory to CPU registers, and the size is decreases here. And then from the CPU register to the auxiliary memory, the size is cost per bit is decreases here. And then access time from auxiliary memories to the CPU registers is decreasing here. So you may be getting you may be asked either of the way, with reference from the CPU register to the auxiliary memory or auxiliary memory to the CPU registers. But you have to remember this one here, size is increasing from the CPU registers to the auxiliary memory, cost per bit is decreasing from the CPU register to the auxiliary memory, access time is increasing from the CPU register to the auxiliary memory. Now we are going to conclude this lecture. So as part of this lecture, we had discussed about significance or importance of the memory. So, so we could understand that one, the memories are as important as the processor here. So one without other one can't exist here. And then memory organization. So the memories are organized in such a way that the CPU could access them with the appropriate with priority here. So first one is CPU registers, and then as per CPU registers, and then followed by the cache memory, and next one is the main memory, and then auxiliary memory. And then here this is in memory hierarchy, the size increases from CPU registers to the auxiliary memories. If other way around, the size decreases from the auxiliary memories to the CPU registers. So that you have to look into statement very carefully whether it is referred from CPU registers to the auxiliary memories or auxiliary memories to the CPU registers. Then access time is increasing from the CPU registers to the auxiliary memories. Other way around, you can also tell that one, access time is reducing from the auxiliary memories to the CPU registers. So last one is the cost per bit. Cost is increasing from the auxiliary memories to the CPU registers. Cost is decreasing from the CPU registers to the auxiliary memory. These were the points discussed as part of the memory hierarchy. Thank you.